Hello, class. We're going to continue our lecture of 6.1, and now we're going to talk about probability distributions and actually how to calculate them from a data set. And so this part here, pretty important, and it kind of lays the foundation for all these distributions that we're going to talk about. And so let's just take this example. And this example states that we have this airport parking facility with a bunch of parking spots. 142 long-term covered that cost $2, 378 that cost $450, 423 that cost 150, and so on and so forth. And the question is, how do you develop this probability distribution function? So what I did here, class, is I've written the appropriate information from that problem in this table. And when you do this by hand or when you do it on a spreadsheet, which I'll show you a little bit later, you see that this table format turns out to be really important. So the variable that we're dealing with is how much each parking spot costs. And the second column are the number of parking spots that cost that appropriate value. As again, for example, there's 57 spaces that cost $4. And so if you add all the spaces up, you get 1,000. And so this is the probability function. And remember, when you add this column up, it has to equal the number 1. And so just like we were doing in some of those calculations in chapter 5 about probability, you take the total as goes on the denominator, and the probability of success for each one of those dollar values goes in the numerator. And so this one would be 423 divided by 100. This one would be 142, or 1,000, excuse me, divided by 1,000. And as you can see, and of course, it usually comes in handy to have a calculator, right? And if we do 3 decimal points, it would look like this. And 0.057. And this one's 378. And so when you add those all together, you would see you get 1.000. So that's how you generate these probability distribution functions. And if, trouble getting to this slide. So we're going to do some more examples as we wander through there, but that gives you an understanding of how to organize it. Put it in a table, state the random variables, figure out the total outcomes, and what each random variable has associated with the parking spots, for example, and you set it up with regards to that. And then if you had the probability distribution function, for example, of something that looks like this, and you want to display it in a bar graph or a histogram. Again, that is, as I warned you, the most important of all the graphs that we do. And the idea is now the y-axis or the vertical axis is probability. And what we have down in the x-axis or the horizontal axis is actually the random variable, which is x. And again, remember, these are both discrete. You can see they're split up that way. And so just like you do a bar graph from chapter 2, I think it was, or chapter 1, what I would do is I would just cut and paste this data and hit copy. And then pull up the spreadsheet and cut the data into the spreadsheet. And let me make that a little bit bigger so you could see it. And remember the generate a graph, highlight the data you want a graph, go up to insert, and here recommended charts, the way to go. And you could see here's our cluster column, which is a bar graph again. And you can see it sets up the grids for you and the X and Y axis. And so when you do these, the first column is usually the horizontal and the second column will be the vertical. But you can change that and the hourglass gives you the ability to change those axes as well, as we talked about before. So how do we compute the mean? That's a little bit trickier, right? Well, the way that you compute the mean is actually pretty logical. And it's set up in such a way where you're given the data. What you want to do is you take each variable and multiply it by its probability function. So what I'm going to do is I'm going to do this again on the whiteboard and show you how to set it up in the table format. And then when we do a big example, we'll walk through that on the spreadsheet as well. And so we're going to walk through this example here. And this is an example of a computer model composed of a very large number of points of light called pixels. And we let X represent the number of defective pixels. And we have 0, 1, 2, and 3. And so the idea is that, oops, clicked the wrong button, sorry. I already put the table up here. And so the next idea is you want to take these two columns and multiply them together. So it'd be X times the probability of each one. So this would be 0 times 0.2, and that would be 0. 1 times a half is a half. 2 times 20% is 0.4. And 3 times 10% is 0.3. So then the next step is you add all these up. And if you added all these up, you would get a mean of 1.2. And again, you see the benefit of a spreadsheet to help you with all this arithmetic, right? At least I hope so. And so if you take a look at our little histogram that I took right out of the book here, you could see that when you're calculating the mean here, and you kind of see where it shows up right here. And what the mean will end up doing is kind of splitting the probability in half, or 50% on either side with regards to that. Okay, so that's the second part of this lecture, which is probability distribution function and calculating mean. The next one is we're going to talk about using these distribution functions to calculate expected value and throw in standard deviation as well in the next report.